Hey guys, this is Yom and welcome to Civil Raja, your gateway to future. So guys, we are going to continue our series on how to study the structural drawing, and in this series we have covered a lot of points like how we can just start like just a moment. I will just show my screen. Yeah. So we have started with what is the importance of the structural drawing, and then we have continued with what's inside the structural drawing, what are the different nodes, and then what is the method of studying the pile cap details, and then we have moved on to piles, and then we have studied the plinth beam drawing, and after that we have studied the column, right? So now in today's session we are going to continue with the study of roof beam design. Okay, so I am just continuing with the same project. Okay, so there will be no confusion at all, and after the completion of this series you will be completely able to just study the whole structural drawing. Okay, so stay till the end of this video, and if you have any kind of doubt like what I've discussed in this video, then you can simply ask that in the comment section. And if you find this video useful, also mention that in the comment, and like this video, share this with your friends and colleagues, and subscribe to our channel if you haven't subscribed yet. Okay, so I'm just going to share the project with you. So here is the project, and we have continued a lot of we have completed a lot of portion over here. Okay, so I'm just going to give you a glimpse of that. So here is the pile cap details, and here is the column positioning. After that, we have the sections of the piles with the columns, and then we have continued with the plinth beam. Okay, and then here is the detailed plinth beam drawing over here. Okay, so after that, what we have continued with, we have continued in like yeah, this rope beam. Okay, so we will continue with the rope beam now, and here you can see the complete page over here. So what are the different things in the rope beam? First of all, we have this rope beam layout. Okay, and then we have this rope beam schedule. Okay, so first of all, let's discuss the schedule over here. Okay, so this is the rope beam schedule. What is a schedule? Wherever we have a table in the like a structural drawing, then you can call it as a schedule. Okay, now what are the different things that you will find in this schedule? So in the schedule of the roof beams, you will find the beam markings, like whatever the beams are used in this particular project, and then what are their sizes. After that, we will like have the details of the bars, like how many bars are continuous, like from one end to another end, how many bars are there, and what is their dia. Also, you will have the details of the extra reinforcement. So in this particular project, in our plinth beam, we did not have the extra reinforcement, so you will learn a little more thing. So if you haven't watched the plinth beam yet, you can go ahead and watch it after the completion of this video, but I will try to cover each and every point that I have used over there. Okay, then we have this shear reinforcement, and then um, we have this side face reinforcement. So if like say bottom length, or you can say the depth of the beam is 500 or more, then we use the side face reinforcement. So in this particular project, we haven't used any such beam with a depth of 500 or more, so we haven't provided any side face reinforcement over here. Now sorry about this. Yeah, so yeah, over here you can see we have this beam markings of 5 types. That means we have 5 different types of the beams over here, and these beams are B1, B2, B3, B4, and B5. So size of B1 is 250 by 350. That means the width of the B1 is 250, and the length of the B1 will depend upon the span. Okay, so that will be mentioned in this roof beam layout. Okay, so over here you can see here we have the length mentioned. Okay, so this whole span, whatever it is using, that will be the length of the B1 over there. Okay, so the length is not marked in the schedule. In the schedule, you will find the width and the depth. So depth over here is 350. Okay, for B1. Then we have no extra reinforcement in the case of B1, but we have the main reinforcement over here, and that is 316 in the top and 316 in the bottom. That means we have 3 bars of 16 dia on top of the beam. Obviously, the cover will be maintained, and the covered in the beam is normally 25 Okay, that you will find in the note section if there is any kind of changes over there. Okay, like in the column we have 40 mm, 40 mm. In the footings we have normally 50 to 75 mm. So in the beams we have 25 mm. Okay. And if we have like a different type of environment, then the cover may change. So that cover is not mentioned over here, okay, because all the beams will have the same cover for a single project. Normally that is the case. If there is any kind of differentiation, then that will be mentioned in the notes section. So I guess I have already covered the notes section in this one. If you have any kind of question related to this beam design or anything related to a study of the structural drawing, then you can simply put that in the comment section. I will definitely answer that in the next video. Okay. Now over here we have this shear reinforcement. That means what you call as stirrups over there. Okay, so that is the shear reinforcement. Now the shear reinforcement are used as 8 mm dia bars. That means 80. Okay, so 80 means 8 mm dia bars are being used as the stirrups, but the spacing of the stirrups are different. So somewhere the spacing are 125 mm center to center, and in the central portion of the beam we have 8 mm dia bars at 150 center to center. Okay. Now why these two like portions are having the different types of the different distances between the steps? There is a reason behind that. Okay, so in the end, so we have the bending moment more over there. Okay, and to counter the fact that bending moment, we need to provide more reinforcement at the ends of the beams. Okay, so at the end, so we have to provide the like more reinforcements. And what are the ways how we can achieve that? So there are basically three ways. First, you can either increase the dia of the bar. Second, you can increase the quantity of the bars. And uh, okay, there are basically two ways. Okay, now that is coming in my mind right now. But or yeah, the third way that has been used over here, you can decrease the spacing between the bars. Okay, like you can keep the same dia of the bars, but you can decrease the spacing. So I cannot increase the number of the like to increase the number of the bars, we can simply decrease the spacing between the bars, and more reinforcement will be provided over there. Okay, so the basic reason is we have to provide more reinforcement at the ends, so we place the bars closer than the central region of the beams. Okay, got it? If you have any confusion, you can simply mention that in the comment section and I will answer that. Okay, now so we have this 8 mm dia bar placed at 125 center to center at supports, and 8 mm dia bars provided at the like means that means the dia of the bars are same. Okay, so 8 mm dia bars provided at 150 mm center to center distance in the central region. Now there are two markings over here. One is ST1, the second is ST2. So ST1 shows the support region and ST2 shows the central region. So how we have to measure that we will see in this detailed drawing. Okay, but before that we need to study the Rubium layout. Okay, so I will just study the Rubium layout over here, and for that I will simply bring the drawing down. Okay, so over here you can see we have a different center lines over here. The horizontal ones are marked as 1, 2, 3, 4, 5, 6, 7, 8. So on total, we have 8 horizontal lines over here. That means different 8 center lines. Sorry, 8 over here, and there is one more 1 dash. Okay, that means the total number of the horizontal lines or horizontal center lines are 9. Okay, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 number of the vertical bars are placed over here. Okay, so this is the situation over here. Okay, now what you can see over here, yeah, so this is known as the center line diagram for the rope beam, or you can say this is the rope beam layout. Okay, so here the beams are positioned, and how to study this center line diagram, I guess I have already made a particular video on that, so we will not invest much time on this one. For now, what we need to understand that here the distances are marked from A to B, then B to C, then C to D. There is another way of marking the distance also, that is A to B, A to C, A to D. I think the for later one is like a better way of doing things, but in the area where I am working, or where this project belongs, that means in the northeast region of the India, people understand this way of drawing. Okay, that means A to B, then B to C. So I have marked it like this. Okay. Now we have this beam over here. So in the beam axis, what is the main thing that you need to notice? Along a single axis, like in the axis 1 dash, you will find B2 only. In the axis 1, you will find B3 only. In the axis 2, you are finding the B3, then 3 B3. Okay. Then in 5, we have B2. In 7, we have B2. In 8, we have B1. Okay. So there is a particular type of beam that is being used in a particular axis. So that is the way of working practically in the field. Okay, so you cannot provide a different type of the beam over here, then a different type of the beam over here, and a different type of beam over here. Like you cannot go with B1 over here, B2 over here, and B3 over here. You cannot go like that. Why not? Because whenever we have to do the construction, so we simply just make the do the shuttering first, right? So we use this formworks, and we need to provide a same like dimension of the formwork over here, so that the casting of the beams can be done properly. Okay, so in the single axis, we normally provide one type of beam. Got it? Now, what we have to study next? We have to study the detailed drawing. Okay, so we will start with the drawing of, okay, let's start with axis 1 dash. Okay, so we will start with this axis over here. Okay, now how we have to provide the reinforcement in this, like how the positions, what is the position of the beams, that will be that we can get from this Rubium layout, like the column positions and the beam positions are provided. But if you want to know how the reinforcements are to be placed over here, and what is the exact dimension of the reinforcement over here, that you can get from here. Okay, so you can see that in this axis 1 dash, we have provided the reinforcement like this. So this bar, the top bar is a 225 also. That means we are using the B2 over here, which is having the dimension of 250 by 350, that you can also see from the schedule, 250 by 350. And what is the reinforcement over here? This is 225 on the top, 225 at the bottom. Okay, so you will find that in this sectional view of the beam also, where you have a 225 T all through bars. That means on the top we have this continuous bars, and this is also having the development length over here. Okay, then what is the development length? That is not marked over here, so I will tell you the development length is 50D normally. Okay, so whenever it is ending at any column, or if the beam depth is allowing that, then it can go for 50D. Okay, and from where the development length starts, actually the calculation of the development length starts from here, this portion, and then it will continue till this depth of the beam, or if it is a column, then that will go till this 50D. Okay, that means if it is a 25 mm bar, then how much can be the development length? That will be 25 into 50, which is 1250. So you can simply assume that this will be 1250. Okay, so yeah, now you can see over here, that will be the development length. Then we have this next thing, that is ST1. So ST1 is basically the portion near the ends. Okay, so whenever we are working with like labors and the masons, they can either go with the rough calculations, and or they can provide the extra reinforcement than needed, which will ultimately lead to the like led to what? Yeah, so wastage of the reinforcement over there, and that will on total increase the project cost, and we do not want that. Okay, so we will go like this, that simply we will tell them how much of the distance will be ST1, how much of the distance will be ST2. So in the like near the ends, we have to go with 1200 mm in this particular beam, and we have to go for 1200 mm on this side also. The rest of the portion of the beam can be like considered as the central region of the beam. Okay, And whenever the length of the beam is changing, we will go for the different zones over there. Okay, like you can see, this is the larger length over here. Okay, so you can see the length of this beam is larger. However, this beam is having the same property, and we are not providing any kind of development length over here because this rod is continuing till the end. So we will provide the development length only at the ends, and this we will not consider every beam as the end beams or every support as the end portion. For the development length, we will simply consider the development length at the end portion. Like if the beam is not continuing after that, then that will be the end of the beam. We consider the whole axis as a single beam. Okay, as you can see, the property of the single beam is assigned over here. Got it? Now, so this is having a longer span. So here the value of the ST1 is more. Okay. Obviously, the value of the ST2 will also be more. Okay. So there is a particular formula of that. And you will also see that there is a particular marking for all the beams over here. Got it? So I guess this portion is clear. Now, what you need to learn? You need to learn about B4 or B5, where we have the to provide the extra reinforcement. I guess this point is clear now. Like near the ends, we have this for let's for example for this beam. Let's consider this beam. Okay, so ST1 is 1200. That means we will place the stirrups at a spacing of 125 mm center to center in the zone of ST1, that is 1200 from this side, 1200 from this side. And for this ST2 zone, we will provide it as like 8 mm dia bars at 150 center to center distance, 150 mm. Okay, so whatever the dimensions are mentioned in this particular project is in mm, so we will go for mm over here. Okay, now let's see how we have to represent the drawing of a beam with extra reinforcement. Okay, so that is B4 or B5. So let's see which beam is either B4 or B5. We do not have any beam in this horizontal portion, so we will check for the vertical beams. And in this one, okay, yeah, here we have this B4. Okay, so here you can see these two supports are closure. So we have this ST1 as 400 over here. Okay, so let's start with a mid-span beam. Okay, so I will just zoom in so that you can see it clearly. So we will consider from this support to this support. Okay, that means 3 to 4. Here you can see the ST1 is 1000. That means we have to provide the extra reinforcement till 1000 from this column. Okay, the distance will be provided like that. Okay. Okay, I'm using this software recently, so I do not know how to mark it. I will just figure it out in the next video. For now, let's yeah, I will just use this one. Okay, so from here till here, we have this zone as 1000. Okay, and then from here to here, we have this zone as 1000 over here. Okay, now that is the case. Let's go with the blue color. Yeah, that is the case over here. Okay, now in this zone we have to provide this extra reinforcement. However, the stirrups will be binded in the same manner, but this 1000 mm also give us an idea of how much length of this extra bar we have to cut. Got it? So that is the case over here. Okay, and anything else that I need to tell you from this? Okay, no, nothing else. So we have to understand one more thing over here, the sections of the beam. Okay, so let's say we will talk about the section 5.5. Okay, so we have a flag marking over here and which is representing the section 5.5. Okay, so we will talk about that. Okay, so let's go for the section of section 5.5, which is marked over here. Okay, so this is beam B2. Okay, and we know that the dimension of the B2 is how much? 250 by 350. So 250 will be the width and 350 will be the depth over here. Then what are the bars that are being used over here? So we have two bars of 25 mm dia which is all through. That means it will start from one beam and it will continue till the end of this whole span. Okay. Then we have this section 6 which is also cutting at the center of the same beam, that is B2. Okay, let's have a section for the B4 which is having the extra reinforcement. So what you can see over here, that we have 3 bars of 20 mm dia at the bottom at the end. Okay, and then we have the 3 bars of 20 mm dia all through at the top, and 3 bars of 20 mm dia as the extra reinforcement at the ends. Okay, now if you will just look at section 1212, which is the central portion of the section, or you can see it will be at the center of this beam 4. So you can see the extra bars are presented at bottom only and not the top. Okay, so that is the also a way how where we have to calculate the central region. Okay, so this is going to help you a lot while you are making the drawing, or while you are like working on the side, that if you will just find a drawing with a marking of HT1 and HT2, then you will exactly know how much of the portion we have to provide this bars at the end, that means on the top, and where we have to provide the bars at the bottom, and consider that as a central region. So HT1 and HT2 markings are very much important on site. Okay. Now guys, if you have any kind of question, you can simply put that in the comment section. Okay, and also hit the button to this video, and share this video to your friends and colleagues, and also subscribe to my channel Civil Raja, so that I can stay motivated to make more videos like this. And if you want to join any professional training, like how you can draft all these drawings, or how we have to design a structure, or how we have to plan the building, or even make the how to make the 3D model of a building, or the interior design of a building, then you can join our professional training. That our course details are there in the description, and also you can call me or WhatsApp me on my number, which is 8433248864, and that is also mentioned in the description of the video. So we'll meet in the next video. Till then, take care. Bye bye, guys. Thank you.